The electric force. Why is it important? Well, your mind probably goes right to flipping on a light switch, and you're thinking, yeah, that's important. And it is. But the depth of it, it's a lot deeper than just flipping on a light switch. Without the electric force, we wouldn't have things like atoms. Why not? Well, let's draw an atom. We've got a nucleus with one or more protons. That's positive. And whizzing around the outside all over the place are these negative electrons. So they're just going all over the place. Why is the electron hanging out near the nucleus? Well, the reason why is because it feels an attraction toward the nucleus, and the nucleus feels an attraction toward it. So if there was no electric force, what would happen? Well, one thing that would happen is this electron might just take off and go this way, and the proton might just sit there, or it might go flying off that way. So if you didn't have this force of attraction here, then you would not have any atoms. Likewise then, if you didn't have the electric force, you would not have molecules. Why not? Because just like the electric force is what holds this electron and proton together, if you've got another atom with its electrons whizzing around out here somewhere, why would they be attracted to each other? Well, the reason why is because this proton feels an attraction toward this other atom's electron, and this proton feels attraction toward this other electron over here. And so when these guys get together, what happens is it makes a chemical bond. They overlap. So once again, without the electric force, you wouldn't have molecules. So what's made of atoms and molecules? Well, yes, of course, we are. So that means without the electric force, you couldn't have things like people or trees. So the electric force, once again, it's important. Okay, also, chemical changes would not happen without the electric force. Just a common example of a chemical change that we've talked about a lot, hydrogen and oxygen make water. Why do they do that? Well, just to use my other example that I've already drawn up here, the atoms are attracted to the particles of the other atoms. And when this chemical change happens, they become more stable because they have less energy. How do they get that stability? The electrons and protons find a new, happier distance that's a lower energy distance usually. Okay, so chemical changes without the electric force would not happen. Okay, so let's go to something that you were probably thinking about already. Circuits. A circuit can be something like a battery flowing with a current flowing through a wire to a light bulb and then back to the battery, or it can be something else. It can be a big cloud floating over with a negative charge built up along the bottom, and then when that happens, the houses and things along the ground build up a positive charge. So what can happen then is you can get a lightning strike. So lightning can zap down toward the ground and back. So that is a circuit too. Basically, a circuit is just a pathway for electricity to flow. So it can be in wires, or it can be between other objects. You know, if you rub your feet on carpet and zap somebody's ear, there's a circuit there. The current is flowing from one person to the other. What's going on inside of a battery? Inside of a battery, there are chemical changes going on. The chemical changes that go on produce electrons that come out of one end, and then those electrons travel through the circuit, and in this case I drew a light bulb. When the electrons get to the light bulb, they crowd through the filament and they get hot, and it gives off light, and then the electrons have less energy, and then they get back into the battery with lower energy. So as they keep going through this cycle, what happens is the battery goes dead eventually. So that depends on the electric force. Generators and motors. Here's a big deal. This is where our electricity comes from. This is how we are able to charge our phones and to turn on our TVs and stuff. Typically, and this is changing, but typically what power companies have is a giant pile of coal, which is filled with chemical energy, and then they take that coal and they light a fire and they burn it, and when they burn the coal, they've got this container filled with water, and the water boils, and we take the steam that's generated and we use that steam to spin this giant fan. It's called a turbine. Not a very good drawing, but anyway. And then the steam condenses, cools off, and we send it back to get heated up again. But this turbine is hooked to a shaft, and that shaft is it spins really fast, and what's going on is the shaft has magnets hooked to it, a north and a south. So magnets have this magnetic field around them, and if you take a magnet and you spin it around in a coil of wire, what happens is in that coil of wire you get electricity flowing, so electrons will start to move through the wire. And what we do is we take that electricity, we put it through a transformer to boost up the voltage, and then we send it out to people's homes. And you've seen things like this before. And then out here is somebody's house, and they want to turn on the TV and play on their computer and so forth. So eventually what happens is the current conducts through the wires, and we have a transformer here to take the voltage back down so you don't burn your house down, and that's it. So from start to finish, what's going on here is you've got chemical energy here, you burn it, you get radiant energy, and then that turns into the kinetic energy of the steam particles. Then the turbine spins, that's mechanical kinetic energy, and then inside of this thing, the generator, you get electricity, and then that goes out to our homes, and then we get to use the electricity. So lots of stuff depends on the electric force.